Hello everyone, welcome to the session Fundamentals of C and Programming. In this short video, let us explore Endianness by using C program. Through this concept, we'll understand byte addressing, byte ordering and byte assembly. Considering a 32-bit multi-byte value stored in a variable x of type integer, your size is considered to be 4 bytes. In this multi-byte value, AB is referred as MSB, most significant byte, and 78 is referred as LSB, least significant byte. Now we'll understand how this multi-byte value is stored in the memory. Considering this as a block of memory divided into 4 different memory locations, for say, this multi-byte value is located at an address 0, then each byte is accessible at a particular address. Assuming A is equal to 0, then AB is accessible at an address 0, CD is accessible at an address 1, EF is accessible at an address 2, and 78 is accessible at an address 3. Through programming, let's declare a character pointer and assign the address of variable x after typecasting into character pointer. Now, from the third line of code, through ptr plus 2, we can refer to a plus 2 address, and after dereferencing it, we can get an access to EF. Similarly, ptr plus 3 will refer to a plus 3, and after dereferencing it, we can get an access to 78 value. So this is called byte addressing. Most of our memories are byte addressable. Now we'll move on to byte ordering. We have two important techniques to discuss. One is big endian and another is little endian. Both of these byte ordering techniques determine in which order the multi-byte value is stored in the memory. For example, in big endian byte ordering technique, most significant byte is stored in the lower address of the memory location, and least significant byte is stored in the higher address of the memory location. The same way, in little endian byte ordering technique, most significant byte is stored in the higher address of memory location, and least significant byte is stored in the lower address of the memory location. In